And let me share my pantalla. So we're finishing module 3 today, okay? And that means for people who don't finish today, you should take the next few days to finish up, because this week you should be studying normal distribution module 4. And you still have time to finish the Connect quizzes. I think I made them available till September 24. If it feels like you don't have enough time, let me know, okay? So where am I going down? Right. So it's in this one, in this photo or the other photo?
No, it's in the module 4.
Oh, okay. Yeah, I better not do it here, because I'm gonna have to go read back how the book defined the terms. Okay, so I'll look at that and I'll respond in the photo, okay?
Okay, thank you.
Okay, thanks. It's funny, it didn't show up here. Oh, I guess on your side it doesn't say if something is in the photo. I wonder if I can fix that, because on my side I can see it says that there are new messages, but yeah, let me see if I can change that so students can check the photo if there's something. Maybe that's the problem. Why students don't check the photo, because they don't know that there's anything there. Okay. Let me put that somewhere. Just a minute. Okay. I'll I'll look at that. And I'll see if I can change the settings in photo to show students that there's comments in the photo. All right, so let's see. Let me check the chat, what you had to tell me about your progress. So let me know what's your progress. How far did you get? Put it in the chat. How far are you? So what you should be doing, what you should have done or should be doing if you're behind, is downloading the 2 packages of notes these are the main notes, and this is like a summary of 4 problems with the question, the data set, and then the solutions. And those are discussed in the notes and then in the video. So these are the 2 videos that correspond. And if there's anything missing in these videos, you can rest assured that it's discussed here in detail. Each page is explained. All right, so let me see. How far did you get? Oh, that's good. If you got up to the weighted mean, I'm happy because that's kind of where I like to start at this point. We have a little time. We'll work with the weighted mean and we'll talk about scatter plots a bit. Great, Adaira. So Adaira, you mean you finished all of Moodle and then you went to the quizzes and the Connect?
Yeah.
Okay. Good, good, good. All right. So anything that you don't feel confident about here that you want me to review?
Um, the weight and mean.
Okay, yeah. So I usually
Yeah.
start there. It's not so clear. Okay. And then I think scatter plots is okay. Maybe you just
Okay.
you can do scatter plots. Did you do scatter plots already?
Um, a little bit.
Okay, so go back today with a fresh look
Perfect.
and get through that. This scatter plots is really important.
Mhm.
And I introduce it here. Okay, let me just summarize so that until this point, until scatter plots, everything I do teach you about is related to one variable. It's univariable statistics. So I teach you how to collect data
Mhm.
for variables, and that's in module 2, and then module 3 we talk about analyzing a variable.
Okay.
And I teach you certain graphics. I teach you how to make graphs or descriptions, illustrative descriptions of the data, and then how to analyze it based on the shape, how to begin to look at the 5 features, how to calculate them, and then how to draw a conclusion. We even talked about last week how you might have to make a few different graphs because you have to make decisions when you're making a stem and leaf plot, and maybe initially you might draw it one way, but drawing it another way with a different, going by a different number or size of interval will give you a different visualization and support your conclusion a lot better. Okay, so I'm just going to read the chat. Okay. All right, so let's look at weighted mean. Okay, give me a minute. I set up my iPad. So don't hesitate to tell me if you didn't get that far. I'm going to start at weight and mean today. And so you're going to see the annotated notes where I solve these problems. In general, the 5-number summary is used to summarize skewed data, and it helps you identify outliers. When data are symmetric, I just want to say this before I get to the weighted mean. When I get to symmetric data, this is the rule for symmetric data, okay? That outliers generally are found outside 3 standard deviations of the mean. And we talked about that briefly at the end of last class. So those are the differences in identifying outliers with the different sets of data. Now, doing it either way will give different results. So you need to know which one. You need to know that for symmetric data, you use the 3 standard deviations rule. For skewed data, you use the IQR 1.5 times IQR rule. So if you don't know what I'm talking about, just make a note, and when you go through it, you'll see that. All right, so we're going to start here. How many people got this far? You guys already, some of you already said it. Don't say it again, but okay, so okay, not bad. Okay. All right, so let's look here. So how do you do this problem? This is a very practical problem. You're in a course and there's components to your final grade. It includes assignments, quizzes, a midterm, and a final exam. Each component has different weight. So although the regular mean formula looks like this says sum up all the values and divide by how many there are. And I mentioned to you last class, whenever you see this symbol here, you should recognize that is that's an average, right? You see the symbol with an n on the bottom, or n-1, or even n-2. This I refer to as an average. Another word for average is mean, but in general, I just refer to it as an average, a kind of average. And now I'm going to tell you that there's other kinds of averages. This average is the case when every observation gives equal amount of information. No observation is more important than another. That's the main point. Okay, so each observation is as important as. But if I treat the components of this of this course as observations, so quizzes, midterm, final, and assignments, if I treat these 4 components as observations of a student evaluation, and I want to combine them to come up with an average grade, if they don't carry the same weight, I have to do that differently. Okay. So going about this, I'll be there in a second. I'm just putting it on my iPad. Okay. All right, you see my iPad now.
Yeah.
So I have
Yes.
great. So let's pretend we don't know anything about weighted mean. Let's just take these numbers. This is the assignment. This is the quizzes. Midterm is over here and the final, okay? And let's say I took 10% plus 10% plus 30% plus 50%. Now I can write it like that, divide by 4, and get an answer. Or I can write it as a decimal. As long as I'm consistent, it doesn't matter. All right, so if I do that, you can add them manually, or you can use, so let's use we could use the stat mode of the calculator, but let's just do, actually, let's just do it manually. You can see that. Okay. So if I said, 10 plus 10, oh, start again, 10 plus 10 plus 30 plus 50, and then divide by 4. Oh, sorry, I grabbed the wrong numbers. I just realized. Sorry. These are not the numbers I need. The numbers I want are not the weights. I want the results. Sorry for the confusion there. All right, so I want the results. So those are their weight. And what I'm going to do is I'm going to use colors. Sorry about that. Let me do that again. So I want the color. So I'm going to use assignments are worth 10%, and that's over here. And then blue is going to be quizzes. Makes more sense. And then the midterm and then I'll put in black, the final. Did I do this wrong again? Assignments. Okay, no, I did it wrong again. Sorry, I'm a bit distracted here. It's kind of noisy in the background. Okay, assignments, 10%, 90% on assignments. The quizzes are 10%, and quizzes were, okay, that's blue. And midterm is 30% worth, so I'm going to put that in green. And final exam, final is going to be 50. All right. Is that okay? Sorry for the confusion. So to organize that data, rather than reading it, what you can do is you can put, you can make a table. And the P stands for the P for proportion. P for proportion. P is used a lot in statistics because it can also be percentage. And it can also be probability. But we're not going to use the word probability here because it's more appropriate, proportion or percentage. All right, so I'm going to write down that it's 10%. I'll use decimals for assignments, and the student earned 90%. Okay, so this can be confusing because there's a lot of symbols and a bunch of numbers you have to group together. So this has a percentage, but also the grade has a percentage. So what you can do is leave the decimal on the weight. So this is the weight. So what's called the weight, the importance or the significance of the result. And you can put without the percentage here. Okay, so because usually, the units of the exercises, if it's millimeters or if it's kilometers for distance or if it's gallons for gas, The units we don't usually talk about until the end, right? We just put it on the side. So we can do that, and that can help clear up things. So for blue, it's quizzes. That's 10%. I can even write it here. This is assignments. Quizzes. And quizzes are here, blue, 100. So I'm going to put 100 here. And then green is midterm. So the midterm was 30% value. And it's 60. And finally, the final has a value of 50%, and the student earned a 50%. All right, everybody follow? That's how you can organize the data. I was having enough trouble reading it for some reason. So then you organize the data. Now it's much easy to see. And you know you got everything because the weights must sum to 1.
Professor, if there are 5 assignments, should you like multiply the first one by 5?
If there, okay, this question does not have 5. 5 assignments. I see what you're saying. We're just getting the total. So on all 5 assignments, total, the student earned 9 out of 10. So maybe the assignments were worth 2 points each. And the student got, anyway, I'm not sure, but that's the total, 9 out of 10. Did I answer your question or no?
Yes, thank you.
Okay, thanks for the question. All right, so let's say we completely ignore this and we just take the values. So going back to what I was saying. So if each component is assumed to provide the same amount of information, then you would just take 90 plus 100 plus 60 plus 50 and divide by 4. And what would you get?
You will get 75.
So that would give 75. And remember, these units were in percent, so you could say your answer, so 75%. But this is not correct. In doing this, what you've assumed is you've assumed every component has equal significance. In other words, you can see this as mathematically, that's the same calculation, right? I mean, this is easier to add them first and then divide by 4 rather than doing them one at a time. But does anyone disagree that these are the same mathematical expressions? Does everybody see those are the same?
They are the same.
They are the same, right? I'm looking on the chat. All right, so they're the same. So in other words, is this the same as well? Does anyone refute that that's the same?
That's
It's
the
the
same.
same.
So they're all the same, right? They're all the same. And what they're doing is by averaging, the assumption is that every observation or every component has equal contribution and weight in calculating the average. And so this is like, what you're doing is you're it's also a weight and mean, but the difference is that the weights are the same. Okay, so you've treated every component as though it has an equal weight. But in our example, it doesn't. So to perform this, you have to do it like this. You have to pre-weigh each value and then sum them up, but the weights will change. And because the final is worth so much more and the student did so much worse, they're not going to end up with 75%. Okay. So let's do that. So let's do this properly over here. And you don't have to divide by 4. Okay, you don't divide by 4 because the dividing by 4 is already happening in the weight. The dividing, the fraction or the percentage is already captured in the weight. So don't divide by 4. Resist the temptation. And then you can enter it into your calculator. Now there's actually the calculator actually does compute weight and mean, and I can show you how to do that. I think like a third of you have the calculator. The rest of you can just, yeah, you can just, it's not a lot of values, right? This is easy to do when there's many values. It's nice to know how to use your calculator to deal with that. So let me bring back the calculator. Any questions so far? So I'm going to enter this regularly on the calculator. So 0.1 times 90 plus 0.1 times 100 plus 0.3 times 60 plus 0.5 times 50. And that's 62. So if you don't get that answer, it's my calculator is calculating with order of operation, PEMDAS. And if you're not getting 62, you need to make sure your calculator has observes order of operations. Otherwise, it would do 0.1 times 90 and then add 1 and then multiply 100 to the whole thing. So, yeah. To put it in order of operations, I think I showed you second format, and you scroll down 4 times and you make sure it's in AOS mode on this calculator. So does everybody get that? You can definitely do this in Excel too. I can show you that. Again, if you ever solve anything on the exams with Excel, you have to send me the Excel document so I can verify your technique. All right. No questions? All right. So, so let me show you in stat mode how I put in and find the result if I was to put this in stat mode. So in stat mode, I have something. So second data is how I begin stat mode. We talked about this last class. Now I want to clear the worksheet because it had something inside. And then I enter the data, and I'm going to enter it in pairs. I'm actually going to enter it in columns. Even though this says X, I'm going to treat this as the X01. And this column as X, sorry, as Y. So this is going to be 0.1, enter, and I scroll down and enter 90. So I enter in pairs. And then 0.1 goes into X2, enter down, and then I put in 100, enter down. And then X3, I enter 0.3, and then 60, and the last pair is 0.5 and 50. So reviewing my results, 10, 90, 10, 100, 30, 60, 50%, 50, and that's it. Any questions about what I did? Nice, Carla. And so then you can ask for the results, second stat. In this case, you use the up arrow and you find it there because this is a product. This is multiplying the two columns, X and Y. So you can actually do this on the calculator quite easily. But you could also, because it's only 4 values, you can do it easily as well. Just putting them in. Does anyone want to see that again? You can review the video. Now let's see Excel. So for Excel, just like Carla did there, make columns, just like I did. You can call this the weight or PI. The way I talk about it is weight and score. Those are the terminology that I use. I put the weights here. The main thing is to clear up what you're doing in the beginning. Once you set it up, you're on your way, right? And for the score, it's 90, 100, 60, and 50. So now I'm ready. So I'm going to put in here a formula with an equal sign, and I'm going to tell to take this cell and multiply with the asterisk with B column. See, by using Excel like this, if you have problems, let me know. Not everybody knows Excel. So by doing that, I can just copy down. And then over here, so now this is going to be a column called weight times score. That's how I think I explained it. The mini videos. And here is the mean or the average. Any questions about the weighted mean? All right, the principle of it is that each observation has a different significance or importance or weight. And so, yeah, the student has a much lower score now. So what I proceed to do with the notes is give you other problems that are weighted means, but I present it slightly differently every time so that you can learn how to identify a weighted mean problem. Okay, so this is the first one that we do. And then there's a second one below. I also use these symbols, right? I use the symbols. So basically, for the weighted mean, it looks different than the divided by n formula, but the weight times score or px1, this is also an average. So I still use the same symbol x bar because it's also an average. So you can see an average by the sum of observations divided by the total or the sum of a weight and a score. The sum of the multiple where the weights add to 1. Okay, so this is our next question. So here the mean score for 40 women in a class is 79. The mean score for 20 men in the class is 67. What is the mean score for all? Now this is also a weighted mean. However, I didn't give you the weights. Exactly. I told you, I gave you information that you can compute the weights, but I didn't give you the weights exactly. If you were to separate this data into columns, how many men are there? There are 20 men. And how many women are there? There are 40 women. And from there, you can calculate the weights. Is this too small for you? Make it bigger. So from there, you can calculate the weights. So the weight for men is for total. Okay. So the weight for men is 20 over 60, and the weight for women is 40 over 60, which you can, in decimal form, 2 out of 6, 1/3, I guess it's fraction. You can leave it like that. You can leave it like that. If you're going to use fractions, and the fraction doesn't make it has a repeating decimal, it's better to use the fraction. And so the men earned 67, and the women earned 79. And now you want the average. So this acts to 100 over 100. So that's going to be, a 1. You always check that. And so if we want the weighted average, we take 20 over 60 for the men and 40 over 60 for the women. And performing this, just multiply and divide plus, so you can do it in pieces. But basically this fraction is a rounding, sorry, it's a repeating decimal, so you prefer to leave it as a fraction. So it's the same principle, it's just that I didn't give you a decimal value. You had to arrive at the fraction or the weight on your own. So it's an extra step. Any questions about that? So because of my calculator observing order of operations, I can multiply from left to right with no problem. You can also do that on Excel. Right, so if you want to round, so some students are saying this is just 33% because this is 1/3. Leave it as, if you do 33, you're rounding. It's not going to have much of a difference here, but my habit is not to round. If you have to throw numbers out, I prefer leave it as a fraction. It's a good habit not to just round like that. In this case, you probably will get the same number, but be sensitive. Yeah, it's a little bit off. So which one is the correct one? 75.04 or 75? You see what I mean? Yeah. So I prefer leave it like that. Not round, intermediate calculations. Got it? Does it make sense? It's a slight difference, but it can have an effect depending on the numbers, and you don't want that. All right, so that's the second example of a weighted mean. So we had to create the weights. It was that extra step. And the third example, if you're ready. So I don't have to do this one in Excel because it's only 2. It's not a lot to work with. But you could. It's fine. That way you don't have to fight with the fractions. The Excel will keep all those decimal places for you. All right, this is up here is the third one. So this one shows you so this one shows you the ages of people in the class. This is so clear in your head now, what's the weight and what's the score? Which one is the weight? Which one is going to give you the weight and which one is going to give you the score? Which is the variable that we're interested in? That's going to help clear this up for you.
The weight will be the number of students.
Good. So right away, you have to clarify, this is the weight. This is where you're going to get the weight from. It is the weight, it's the significance of the result. And this is your variable or your score for your variable. Okay, so the variable, it seems so elementary right now, but when you're in the test, you'll see in some of the questions, you know, you have to be very clear when you're studying, what is the variable of interest? The number of students is not the variable of interest. You're interested in age. But this is telling you the significance of each observation for age, okay? So we have the weights as a number, a count, but we really need the percent weight. So we want the weight as a percentage. This is the weight as a count, but you want the percentage. So you could, so this is the difference between this one and the last one we did with men and women. There were only 2 observations. How many are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to be efficient. And a way to be efficient here is to tally how many students are there in total. Because then you'll know what each of these numbers represent as a percentage. Weight. So how many students are there?
667.
Very good. So the total good. So we have 2 options. In this case, what we did was we multiplied each one because there were only 2. But what if we did it like this instead? If we did x bar equals 20 times 67 plus 40 times 79 divided by 60. Would that be the same?
Yes, that would be the same.
Yes.
Yes, you feel it's the same, right? So let's, for this, so for, in this case, I wanted to show you how those were weights and that don't compute the weight, just use the fraction. But we could have done it like this, pre-multiply by the weight of 20, and then to get the percentage, divide by the total. So we're going to use this technique just because there are 9 observations and it's too messy and we could make a mistake. We always have to think about that. So what we're going to do is make 18 as our, so we're going to still use the same idea, right? The weighted average is score or weight times score. That's how we're doing it. Weight. It actually doesn't matter which order you do it in because you're multiplying, but that's how we're going to do it. So weight is going to be 14. I'm going to put the brackets on here. So 14. And then, so that's the weight, 120 times the score plus 200 times the score plus, so all the way like that. So 200 times, no, I can't do it like that, times 21. And then 90 times 22 and just keeps going. 30 times 23 plus 10 times 24 plus 2 times 25 plus 1 times 32. You're going to add all those up. It doesn't look great the way I've done it. And then divide by 667. Let's see if I have them all. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. To do it faster, you could write like this. And then just, so multiply, sum, and divide by 667. If you want to convey to me what you did. Notice it's hard in the transcription from putting it down here. You could easily make a mistake. So try and work from here. You know, if the actual data, it's actually easier if you work from here. Because you might, by copying, write something wrong. But if you want to convey to me what you did, this is sufficient, what I did here. But this is what you're doing. And what do you get when you do that?
$21.
Is there a fraction there? I mean, a decimal?
This is 20.5757.
I have it here as, so I wrote it as this, and then 1 divided by 667, 20.58. So it's like 21. Yeah, if you round it. So in my instructions in the notes, I tell you how to deal with the fractions or the decimals, sorry. Deal with the decimals. Round till 2 more. It's written in the notes earlier on. When you're done, you round your final answer. And if you follow this rule, you usually get the same answer as me. Round final answers to 2 more. Two more decimals than found in original data. Okay, so what does that mean? It means since there are no decimals here in your original data, your final answer can have 2 decimals. Okay? It's just a way so that you feel confident that you got the right answer and your answer corresponds to my answer. Most of the time, it's only a few times where I don't follow my own rule. It's going to be like that. And why will this make a difference? It makes a difference when you're studying, just to feel confident that you've done things correctly. In the end, the tests largely are multiple choice questions. So you want to be able to identify, you know, your answer. With mine, I've never really had a problem with it, but I teach this early on so that just to avoid any confusion. So this would be the final answer for this problem. And then maybe if this was a multiple choice problem, you'd have options like 20 and 21, you know. And you should know this is 21 if you rounded it. All right. Okay, I'm assuming no questions. Okay, so I've written something here. All right, so I just showed you in the first example, we were given the weights and we used the principal weight times score, summing them. In the second example, we used like the frequency or the count. I call it the count times score. And then we divided by n because these are really weights. And the third example, I used frequency times score, and then just I divided at the end. So they're all the same thing. All right, they're all the same formula. They all mean X bar. So if I refer to the general formula for mean, it's not forcing every observation to have the same weight. They could have different weights. So this is the general formula for the average, or it's called a weighted mean. Any questions? So don't worry, you don't have to get caught up in all these formulas. They're actually supposed to help you. If they're not helping you, get to the point. Let me know if you're getting confused, but this is to show you, don't worry too much. Basically, you can get to a weight even though you have a count by simply dividing by the total.
Professor, I have a question.
Yes.
Would you mind going back to the first exercise that we did?
Yes.
I don't remember if it was there, but you said to make sure that it summed like 100 over 100. I'm not
Yeah.
sure if it was in that one or in the second one, and I wasn't sure what you meant by that.
Oh, that these have to sum to 1.
Oh,
The
okay.
weights.
The
So
weight always has to
And then
sum to
also the count, yeah, this was not 100. What
yeah,
was
it was in the
That's
second
where
one.
I confuse you.
That's
Okay,
what I was
yes.
thinking about.
It was 60 over 100. No. Okay, so it's 100. Anyway, this has to be 1, sorry. 100 over 100. If you did the algebra here, this would be 100, but I
Right.
guess I have an in-between step missing. But it should make 1.
Okay.
So this
Thank
is
you.
60 over 60. It's not 100 over 100. Let me fix that. Thanks.
I was so confused.
It is the
Okay.
same. It is the same. It's 60 over 60, which is also 100 over 100. They're all the same because they all make 1. But yes, thank you for that.
Thank you.
It's like I missed a step there. Thank you. Other questions? All right. Now this brings us to the weighted standard deviation. If there's a weighted mean, there needs to be a weighted standard deviation. And I introduced that here, and you shouldn't try not to be intimidated by it. It's not a big deal, but it does look intimidating. I agree. So here's the regular standard deviation formula. I asked you all to watch the video on what this formula means. This formula is the average, it's the square root of the average square of the square deviations from the mean. So it's the square root of the variance. So they're both averages. They're both kinds of averages. And from that idea, what if you don't have observations with equal weight? What do you do? Well, this would be the weighted mean formula. So I'm replacing this with the weight. And that weight provides, provides information for us. What if we don't have the proportion weight, but instead we have the count? It looks like we're back here. Like, okay, so if we have the count, so let me go back up here. So this is the one where we have a lot of data, right? Now doing it this way, 14, 18. So this is like a summary of the data. This is a table that gives you a summary of the data. And it shows you when you're looking at it that most of the observations are over here, right? So when you're looking at this is a kind, even though it's, I haven't drawn anything, I've grouped the data together in a way that, what kind of shape would you say this data has? Symmetric or skewed? There's no drawing
Okay.
here, but I've grouped together common terms. It's what a drawing does, right? So I've put there's 14 18s, there's 120 19s, there's 220s, so most of the data is here. 400 of the observations of 667 observations are right here. And then it starts to peter out. And this is way further from 25. So what shape does this distribution have?
It looks like it is right skew.
It's right skewed, exactly, because this is further away. It's not, the drawing would help keep the distance, as a number line would. So this would actually have to be way over there. But anyway, emphasizing that there's a right skew on this data. So you can see it. So really what the data looks like, if I was to write it out, would be like 18, 18, 18, 18, 14 times, right? And then 19, 19, 19, 19, like 120 times. So the data is really like, it's a lot of data. You have 667 observations. So just keep that in mind. That's what you're staring at there. So I always like to try and make things look like what we've seen before, so we don't feel like we're learning a lot of new things. We are synthesizing what we learn when we do that. We're synthesizing better, right? We're saying, well, we saw this before. So in this case, this is telling you, think about that when you look at your data. So when you see a percentage, it's not as easy as just what I visualize as when you see the frequency of the data, right? So you see you have so many observations, and this is how you would calculate the standard deviation in that case. And because you're able to see them and count them, we're back to this kind of thing here, where we have to make this adjustment because of what I mentioned to you before, and it's written in the notes, that statisticians noted that you would be biased downward, and you want to adjust that. You don't want a small standard deviation if it's wrong. You prefer to have a larger standard deviation, or you prefer to overshoot your standard deviation rather than to underestimate the standard deviation. So this adjustment makes sure your standard deviation is a little bit bigger and captures the spread of the data. So anyway, so that's mimicking that one there. And don't get intimidated by this. These just have to add to 1. These have to add to n. Frequency. All right. And then I did this. I made a long video. This is my most popular video. I don't know what ended up that they saw this video in Indonesia or somewhere in India. And I have like so many views on this video. Like I think 10 over, I can't remember. It's tens of thousands of views. And so this is how you would calculate the weighted standard deviation. Do you want me to do this, or do you think you can watch this video so we can move on? I still remember doing this, and it was tricky for me. You have to be careful about the steps. Who wants me to do this? You can do this in Excel. We could do it in Excel nicely. Carla's showing me something here. Yeah, Carla did it in Excel. Beautiful. It's in the chat. And you guys can use Excel. That's fine. My approach was always to be able to do problems in 2 different ways at least. So then, because you don't have an answer key in a test situation, if you approach it in 2 different ways and get the same answer, you're confirming what you got is the right answer. Okay. So it's good to be able to do things in 2 different ways, your calculator, Excel, and even by hand. So Joshua's asking, what's the most efficient way to get the result? It depends on the data you've been given. I think it's to put it in the tables. I think putting it in the tables is the best way. But you should equally be able to do this manually with small data sets. Okay, who wants to see this this problem? the weighted standard deviation. Yeah, Christina?
I also want to see the
Process? Okay, so I do
process,
have the
yes.
video, so I'll do it and then you guys
Okay.
can check back.
Yes.
So I do make a note. I'm going to do it. I'm just going to make my note here. All the formulas for means and standard deviation above were for a discrete variable x, not a continuous variable. So what am I saying? So even though in this course I told you that once we left module 2, we were going to focus on continuous data, and interpretation for continuous data. But then when I make these calculations, because I cannot assume you learned calculus, we need to work with discrete variables. Discrete being that, look, I can present to you here the observations as a list, okay? So I show you the observations as a list, and we calculate, in this case, with a probability, we can get means and standard deviations, and we're doing that as though we're doing it for a discrete variable. But in fact, it's a similar approach for, and we're going to do this, we're going to talk about this more in module 6, about continuous variables and how it's a little bit different, but okay. Basically, I'm listing the data, I have the weights, and I want to get the standard deviation. First, I need the mean. So let me do this in Excel for you. So I'm going to say, I can call it, I put them in different columns. Does it matter? It doesn't really matter if they're, because you're multiplying. Doesn't matter if, so just back to what I was saying. So there were 3 different problems that I showed for the weighted mean. They were all the same answer. Like I had to use the weighted mean, but they were presented in different ways. So the goal there is first identify your weights and you're on your way. You have to identify that you need the weighted mean because every observation has different significance. Once you get the weights, organizing your data, you're on your way. Okay, so I have the X, the observation, and the weight. I put it on this side. Does it matter if it's on the other side? Doesn't really matter. I'm going to put it on the other side just to stay consistent with what I did before. Okay, so I'm going to multiply now. I'll do it down here. Actually, I'll do it up here and then I'll scroll up. So this is going to be to calculate the weighted mean. So remember, weight times score is what I need. So I do that with this one, and then I put a asterisk, and then I pick up that one. So that's the weight times score, and then I copy down the formula by going like this. That works as long as I have a column already entered here, it knows that I want to go up to here. And then this result, the sum, equals sum of these ones, gives me my weighted mean. So now I have the weighted mean. I'm going to take this data here I'm going to start over down here. Just going to keep that because I need that value. And so we begin with the calculation of the standard deviation by getting the deviations from the mean, right? The deviation from the mean. The deviation from the mean is the value minus the mean. So this is the value, be careful, pick up the right one, minus the mean. I'm going to, oh, I could do it like this. You know what I'm going to just write? I'm just going to put 9.1 right in there. It's easier. Right? And then I'm going to copy it all the way down. So once I have that, I'm going to get the deviation from the mean squared because I know if I'm to sum these, actually, let me show you that. Let me show you that. If I was to not square them, and I'll do it down here. So let's say I wanted to just completely forget about squaring them and take the deviation from the mean and weight them and get the weighted average or the weighted mean, right? I'm going to get the weighted mean of these values. So what would that be? That would be, actually, you know what? I'll do it up there. I think it's going to look okay. Clean it up. So let's say I did this. Let's say I took the weight and I multiplied it by here. So follow me because I want to show you a point. I don't know if I mentioned this in the video. So this is the weighted deviations from the mean. And if I was to sum them, what should I get? Does everybody remember? What should I get if I sum these?
Well, you should get a 0.
Yeah. Woohoo! You see? So it becomes 0. It becomes 0. Now this one won't become 0 because these are not weighted. These are just, without the weight on it, it's not going to work. Shouldn't work, right? It's a number. So don't do that. You have to do the weighted deviations from the mean will give you 0. And that justifies why I have to square. So now I'm going to square. I'm going to square this over here. That's kind of why I didn't want to put that column there, but it's very important to realize why we have to square. Okay, so we're going to square. So what I'll do is I'll just highlight this with a color. Okay. So I'm going to square this one here. Well, actually, I can just copy down at this point. So to copy down, you go like this and you get the little cross. And that's it. So now that I've squared them, I don't have to divide anything. This total here, if I sum them, this is called the variance or the weighted variance. This is a sum. Okay, so the sum of the square deviations from the mean is the weighted variance. And then I need to get the units back. In this case, it was the spending data. So it was dollars. I need to take the square root. To get the square root, you use SQRT and bracket. So this is called the weighted standard deviation. Oops, something happened. What did I do wrong? Hold on. Something's wrong with my numbers. Square. Oh, again, I forgot the weight. I keep see that's the thing I always do. All right, so now I have to put the weight here. I'm not done. So I have to weight those square deviations from the mean. I could do it in a separate column. Let me erase this for now. Okay, so I could put it in a separate column, but I'll do it all at once. And it's easy enough. I'm going to put that this multiplies all the way down. Sorry about that. You guys didn't stop me. Let's see, someone, so no one wrote in the chat. Okay, so then that's what I do, but I could do it in two separate steps. I could do the square deviations and then square deviations times the weight, but I'll do it all together. And now sum. And now that I've summed, this is called again, the sum is equal to the weighted variance. But we really want the standard deviation. Because that will put us back in. So we take the square root, it puts us back in dollars. So this is $5.14 or $15. Questions? You don't have to put the yellow column. I just wanted to prove to you why we square. So we square, we pre-weigh. So that weight, with that weight, you have to get the weighted mean first. Let me write that weighted mean. Sometimes we don't even say the weighted mean. Once you know what data set you're working with, you should realize, it's the weighted mean, but I'm doing it here because you're just learning. So it's the weighted mean. I get the deviations and I show that you have to square, because otherwise the weighted average will be 0, the weighted average of the deviation. So you square them to retain their, we don't care that they're positive or negative. We care about how far the values are from the mean. So to maintain the magnitude, we just square and then take the square root to get back to dollars. Questions? Do you want me to put this on Moodle? I can put this as a screenshot. So I'll take a screenshot and put it there as a memory. Okay. Okay. So, so this technique comes up again. We're gonna talk about this again in module 6. But otherwise, yeah, you need to know the basics. Any questions about the weighted mean, the weighted standard deviation? Okay, so then I go on with a discussion about scatter plots, which I don't want to reiterate. I just want to encourage you to make sure you look at that. Maybe I'll show you a slide or two here. Okay, back to my iPad. Okay, it's 10:30. Okay, let's see. So yeah, this is the idea, right? So we're going to look at two variables at a time rather than one and talk about their relationship. And I focus on a linear relationship, identifying a linear relationship. And you can see here, there's a linear relationship between two variables. The way that we draw or illustrate two variables, and you should always do this if you're looking at two variables and their relationship, is to make a scatter plot. I review how to do that. So here you see a perfect line. You distinguish that with this statistic that I teach you about called the correlation coefficient. Now, this is the extreme perfect, best relationship in terms of being able to say X and Y are perfectly related within this range of data. Outside of that range, like way over here for this variable, a value of X, you don't necessarily know that you're going to get the Y that's up here, but it's not a stretch of the imagination that that line extends. But you have to be careful to use this data to make predictions too far outside, okay, away from the data. And I explain that to you with some examples. Here's less, perfect, but it's pretty strong correlation between the two variables. So, if let's say, in the examples in the videos you learned about the number of drownings and the number of the sales of ice cream. So maybe that if you plotted it, you would get something like this, 80% correlation. Remembering that one doesn't necessarily cause the other, but they're both picking up on phenomena that are because they're both being affected by the background environment, right? And so we're able to look at those and see that there's a correlation. So this is just would be a strong correlation. The strongest, of course, is when they're perfect on a perfect line. And this is an example of no relationship. Like you can't see a trend. You don't see up trend or even downtrend. It's flat. If anything, if I wanted to put if I wanted to represent the data with a line, the line would be flat. Would you agree with that? And the idea of the line, putting a line through the data, is to say the line would sit closest to all the points. So it's like finding a midway point through the data, and that one would be a flat line. In this case, we say there's no relationship and no linear relationship at all. And in that case, the calculation of that statistic that you're going to learn about is going to be 0. So this just shows you the range and the interpretation of the data. The statistic comes after, right? You don't calculate a statistic until you see the data. It's very important. And I'll illustrate that down here. So here's the opposite, but this is still a strong relationship. This is a perfectly negative relationship. And I give an example of that. And this is another relationship that's negative, but it's not perfect. However, and it's scattered around. And if I tried to make a prediction out here, I wouldn't be so confident as I would making a prediction in this with these two variables, right? Being out here, I could predict, I would feel comfortable because it's so tight. This relationship is so it's so predictable. But here it's not. It's like, okay, well, sometimes it's high and sometimes it's low. It's pretty scattered around, but it does look like it's going down. As X goes up, Y goes down. So as X increases, Y goes down. Now here's your catch. Here's the problem here. Now this one, there is a relationship here. It's a curve, but it's not a line. Okay, that's the point. So we call that a nonlinear relationship because there's no line, but there's clearly a relationship. I can predict one from the other. In between those dots, I feel pretty confident that I know what's happening with these variables. So some examples I give of this is you'll see some examples. Actually, I have the curve the other way in my example, but but really this is a relationship. It's just not a line. It's a curve. Now, we don't have time in this course to talk about making predictions with curves, but in Excel, you can make predictions with predictive lines with curves, and I'll show you that So I'm also going to show you how I use the data keys on the calculator to compute the weighted mean, and how I used it to calculate an average and standard deviation, all that. We're going to use those keys as well to calculate this R and to calculate the least squares regression line, or the line of best fit, or the line that fits closest to all the points that I'm discussing here. If you were to do that on this curve, you would get a line that's pretty flat, maybe a little bit up, but pretty flat. So the R would be close to 0 or 0 on this, but that's not appropriate. You shouldn't use the R calculation unless you have a line to look at, okay? Or a scatter like this. Because it's going to, if you just, again, at the very minimum from this class, you're going to take away from this class that if you get data, draw it before you make any calculations of statistics. You need to look at the pattern of the data. In this case, with two variables, if there's no line, you shouldn't calculate an R statistic, okay? Correlation coefficient. So those are just some things I want to say as you finish your review of correlation. And what would you like to do now? Would you like to start the normal distribution, or do you want me to give you some problems? Like we can look at some old exam questions for graphing and descriptive statistics. Which one do you pick? You want to do normal distribution, put it in the chat, or you want to look at old exams? Okay. Let's do some old exam questions practice. Yeah. Okay. So I'll pull up some different problems. Let's take a 5-minute break. Take a 5-minute break. We'll be back here. Oh, more than 5. So let's be back here at 10:40. Okay. So old exams. Okay. 10:40. I'm going to pause the video. Okay. My camera. Okay, so why don't you try these two? I'll leave these two. Well, no, there's one right now. Let's try number 2 first. Let's do number 2, and then we'll go to the next one. Trying to make it bigger. Is it big enough for you? There.
There, please. Thank you.
Sure. All right, so this is about histograms. Did you got a chance to see the histograms? I hope. My hint is just identify the variable first. It'll make everything easier. You can put your answer in the chat. So what is the variable here? What is the variable? Okay, so let's see. I'm going to put up my iPad again. Okay, so the variable, we would like to make a histogram of the number of thefts. Now this, once I tell you it's a histogram, this should make it, and they're asking you for the horizontal and vertical axis. What is the vertical axis of a histogram? Right, and the histogram, the vertical axis is always the frequency. So that would that would mean that because we want a horizontal and vertical, that means that the second one, the vertical, should always be frequency. The only ones with frequency are these two, A and D. All right, so now number of thefts and frequency. This is confusing because they're both numbers. Like number of thefts is a count and frequency is a count. But what we're going to do with this histogram is along this axis, we're going to divide in intervals, right? There's going to be intervals of, and it's going to be like, I don't know, 100, 200, 300. Okay, so I hope you can see that. Maybe I'll make it bigger. I don't know why I'm writing so small today. So we have the variable here in groups and we're counting how many cities in all North American cities have between 0 and 100 and we're putting a bar, 100 and 200 and we're putting a bar. So we're counting, we have the variable of thefts, vehicle thefts across here and counting the frequency of cities. Big cities, I know that's another way to avoid confusing yourself, you know, the number of big cities that had that many thefts. So yeah, this is confusing for sure. If you got this wrong, don't feel so bad, but you got to clear it up, right? So that the second, the vertical has to be frequency. It's one of those. So it should be A is the answer. And some of you did get that, but it was challenging. Okay, so the vertical axis is number of observations, or sometimes if you have a relative frequency histogram, it's the percentage of observations, but still it's the number of observations or frequency of observations. Let me see how many people got it. So to replace this, to avoid confusing yourselves, just say big cities. Okay, so out of the big cities, how many of them had car thefts between 0 and 100, 1 and 200, 200 and 300? So yeah, like this was a confusing question. This one, anyway, there's often a question like these in the reviews. All right, so let's make you feel better. Let's try the next one. How about this one? So let's see how I can fit this. Let's do one at a time. So you can see this as a histogram. If I a stem and leaf plot, call it histogram. So it's like a stem and leaf plot, but you can see if I put the data out here, right? I don't have the data listed, but 7 observations are here, 15 are here, 24 are here. So you can see, so it's kind of like the makings of either a stem and leaf or a histogram. So what do you say? Oh, I gotta move this. Okay, some mixed responses. For people of that one, try the next one. Hmm. All right, I'm looking at your answers. I'm gonna go back for a minute. Over here. What did we learn here? If the data are symmetric, the mode, median, and the mean are in the same place. So they'd end up in the same class, approximately. If the data are right skewed, the mean is pulled towards the tail on the right, so the median is lower than the mean. The median is lower than the mean. If it's left skewed, the left tail, sorry, is a drag on the mean. So the mean is always affected by the extremes. If the tail's on the left, the mean is on the left or lower than the median. All right, so you want to change your answers? Anyone? So I go back to the question, right? Let me go back to the question. So what I see here, if I flip the data, is I see most of the data over here and then a few observations on the right. So this is right skewed. So then I have to choose between A and C. And because it's right skewed, the mean is on the right or it's higher than the median. So the answer, or let's say it the other way around. So the median is smaller than the mean because the mean is on the right. So the median is smaller, C. Okay, so I got a mixed set of responses, but I hope you get it. Okay, so it's right skewed and the mean will be on the right of the median, so the median is smaller. All right, try number 4. I'm going to move this down here and then make it bigger. And a box covering that. How many observations are here? So if you want to sum these up, let's try it with you want to sum up how many they are. So let's use the stat mode. So I got to clear that. And I'm going to put these values in just to the X. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 classes, right? So 7, enter down, down. 15, enter down, down. 24, enter down, down. 18, enter down, down. 6, enter down, down. 5, enter down, down. 3, enter down, down. 2, enter down, down, and 2. And then I'm going to see the results, and I get the sample size, and I get the mean, and I need to multiply that by 9. So this is 82. Is that how many you got? That seems really high. Let me look at my data again. 7, 15, 24, 18, 6, 5, 3, 2, 2. All right. If you want me to show you what I just did, let me know. So that's sample size 9. This is the mean, and then I multiply by how many classes I added together. So 82. So that's a total of 82. Questions so far? So there's 82. And I have to find the median to get the second half of the data, right? So n plus 1 divided by 2 is 83 divided by 2, which is 41.5. So it means that the median in between the 41st and 42nd observation, observation in the ranked list. So let's write down, let's do a cumulative. So we're going to make a column that's called cumulative on the side. And we're going to add up as we go along. So there's 7 in there, but together in the next one are 15 and 7 below. So 15 plus 7 is 22. Then 22 plus 24 brings us to 46. Do you understand? So 46 are below that. Keep going. 46 plus 18 is 64. We're not at 82 yet. I mean, we're not at, oh, yes, we passed 41. Okay. So in here, where you can see that is the, this has the most observations in it. So this is the modal class. It's the class with the most observations. And it happens that the median isn't there. Okay. So usually that will be the case. And, or near to it. So in here, the 41 and the 42nd are in here. But there's still some more observations after the 41 and the 42nd. So, so after this, we have the second half of the data. So the second half of the data is where the third quartile will be found in one of those. Let's continue with the cumulative list. So 16 and 6 is 68. 68 and 5 is 73. 73 and 3 is 76. 78 and 80. Did I miss something? So I added something wrong.
I think I got 80 instead 82.
Oh, when you added?
Yeah.
I must have added something wrong. Okay, that works. But then I have to redo the whole thing. Cool. Let's do it again. Let me go back and look. So 7, then 15. Okay, let me do that again. So 7 plus 15 is 22 plus 24 is 46 plus 18 is 64. Oh, that's where I got it. I lost it. That's where I lost it. Is that right? 46 plus 18 is, yeah. 46 plus 18 is 64. So there we go. And then plus 6. So all of these are wrong. So 64 plus 6 is 70. 75, 78, 80, and 82. Okay, are we good now? 82. So n is still equal to 82. And then n plus 1 over 2 is going to be 41.5. So the median is between the 41st, sorry, 41.5 and 42nd observation. And the 41st and 42nd fall in here. So we're going to find the third quartile in here. What we have to do is we have to divide the second half of the data. How much data is in the second half? 82 divided by 2 is, where the n is 21. The 21 observations in, no, that's not right. Sorry. $41. There's 41 observations in the second half. So now you have to divide that in half. So I'm doing that in red. N plus 1 over 2 is 42 over 2 is, that's where my 21 comes from. So 21 observations. So we're going to start from here. Are you guys with me? Did I lose you guys anywhere? Should I leave you? I'll let you figure out the rest. Let me let you figure out the rest. And you've done a lot already. How are we doing? Okay, so let me tip you off here. So, after the 42nd observation, you're going to start or at the 42nd observation, you're going to start the second half. And you're going to have 42 in there, the 43rd, the 44th, the 45th, and the 46th. And then you keep counting from there, but use this, I think this is the best way to do it. So it should be in here, right? Because we want to get to the 21, or maybe not. So this is actually very challenging. So you have 1, 2, 3, 4, 5. And then you have 18 in the next one. So what does that make? That makes 23. So that means it will fall in here because the 21 will be in here. Does everybody see that? Oh. That should be the answer. Did anybody give that answer? Yeah, A. Good. Good. So was that hard? That was a little challenging, but you got it step by step. Many places to get lost in that one. Many catches. Okay, so should I review? What we did was interpret how many observations we have accumulated to the end of each class, because we need to count. We have to count up to 41 and 42. So we have to get into 41 and 42. And thankfully, they both fall in here. So then we divide the data in half. The median is in here. And we divide the data in half. And we begin with the second half at 42. And we count the 42nd, the 43rd, the 45th, 4th, the 45th, and the 46th are all in there. And that brings us to the next class to find this is where I should make a note here. This is where the third quartile is the median of the second half of data. And that's the rule I'm using. So I divide the data in half. I find the median. The median was in here. At the 40, between the 41 and the 42nd. So then I start counting at the 42nd, because the 41 and 42nd are not the median. It's the average of the values, 41 and 42. And then I take these values and I keep going. And I see that that's going to be 23 observations altogether. So the 21st must be in here. All right, so you guys did pretty good on that one, but it does take time and you need my help. That's okay.
What I got a little confused, I understand now, but what I got a little confused is that when I summed the 21 to the 42, I got to 63. There was then I was looking at the speed intervals instead of the frequency counts.
Yep. Yeah. There's a lot of numbers. It can be confusing, but yes. Yeah, you have to look over here. All right. All right. Well, one more. Let's see. Maybe you have time for 2 more. Okay. What topic do you guys want to see? Do you want to see box plots? What do you want to see? Let's see what you want to see. I'll find something. Which one bothered you? Which one did you feel? Which topic you felt uneasy, unsure? Patricia is asking if Q3 can be 0.75 of N. That's one way to do it, but you might be wrong with these exercises because these exercises use this technique, Patricia. But in real life, that's a fine approximation of Q3, but in this course and with these problems, you have to do it this way, okay? It can be wrong sometimes. And the other thing to say is that even if you use Excel, you might get a different answer because Excel does it a little bit differently too. So unfortunately, most things are standardized in statistics except for the 5-number summary. I don't know why, but we're just going to do it this way. Okay, so 61.5, see, so it's not even in that quartile. So yeah, you're going to get the wrong answer. So be careful, Patricia, do it this way. Joshua wants to do another one like this. What I can do is I can give you one like this to take home and we can look at it next week and we'll do something else right now together. How about that, Joshua? So give me another topic. There's so many topics. Let's see. I'll flash some of the questions. Do you like this one? Which one do you like? So many good questions. So let me give you one more like that one. He wants, you can, let's see. Okay, try number 6 for home. This is for homework, okay? So we can look at this next week, this one here. Number 6. And come with the answer for next week. Or you can watch the video if you're not in the class. I'll do it at the beginning of the class. Okay, so this is for homework for next week. And what other topic do you want to do? I kind of want to do one of the things with graphs in it, one of the problems. When I take a screenshot of that, I'm going to go back to the graphs. Oh, there's so many good questions. Okay, which one makes you more nervous? This one or this one? Number 2 or number 1? Which one do you feel more nervous about? 2. They both make me feel for you guys. Okay, this one or this one? Okay. No, we can make this one. Okay, the one that we won't do, we'll do for homework as well. Okay, so let's pick one. Okay, put your choice. Number 1 or number 2 for right now. Number 1 or number 2. Okay, more ones. Okay, so take this one for homework. Take a screenshot of this one. And we'll look at it. Okay, so take a screenshot of that one and we'll do those in the beginning of next class. And I'll do number 1. Well, I'll put up number 1. You guys can work on it. So if you have to go, if anybody has to go, you can go and come back and see this at the end. Because I'm going to finish this number 1 problem. So this one. And then we're going to go. So if you need to go, just go. But I'm going to do this properly before I leave you. So let me give you a few minutes to try that. I'm going to mute myself. Okay, let's get going. There's a few extra steps you have to do in here and use this table to figure it out. All right, which of the following statements are true? The distribution of scores for section A01 is skewed to the right. So A01, if you need, you could take it off, or I'll take it off. You have to visualize this like this, right? And what do you say? Is this skewed to the right or skewed to the left? How do you check? You check outside of here and you notice that the left is longer. So left skewed on the outside of the whiskers here. I wrote it wrong. Left skewed. On the inside of the box, you check on inside now, which one is longer? The left side looks longer, contributing to the possibility that this is left skewed. Okay, so it's always on the left. So it's not right skewed. So this is wrong. A is not correct, or statement 1 is not correct. You can do that over here too, but I'm trying to show you the number line concept over here. All right, now, number 2, about 50 students in section A2 received a score of higher than 71. All right, remembering that the data are divided by each quartile. So there are 25% of observations in here, 25% in here, and 25% and 25% here. So 25%, not 25. Now it's saying here 50 students. So how am I going to figure out if 50? Now let's look at the 71 ideas first before I continue. Okay, so this is 60, about 60 is the median. And then I guess you need a ruler, but that's like about 70, 71. Would you agree? So this line here, the third quartile is around 71. All right, so the question says, how many received a score higher than 71? So this is how many students is this? It's 25%. So you need to go to section 2 and notice that N is 200. So what is 25% of 200? It's 25% times 200. Okay, when you say of, 25% of is 25% times, which is 50. So that looks good. How many people got that one? All right, so this looks good. If we constructed an outlier box plot, we would see that there is at least one outlier in O3. All right, again, we have to go to the data. So we see this is the final, the maximum value. So is it possible, because this is right skewed, right? It's right skewed inside and it's right skewed outside, or it's like longer on the right side or the upper side. So we're going to check if there's outliers here. And to do that, we have to calculate the IQR and then multiply it by 1.5 and extend it out. So let's see if I can just do that on here. So this is like 1.5. Yeah, this looks like there's going to be something there, right? So let's do the numbers. Let's make the number calculations. So we're using this data here. And we don't need these. We see Q3 is 66 and Q1 is 49. So we can calculate the IQR. And what do you get? $17. So the range here is 17. right? So that's the range there, is 17. Now we're going to take the IQR. We're going to multiply it. Multiply it by 1.5. And what do we get? 1.5 times 17 is how much? $25.5. And now what do we do? We're going to take this distance, we're going to add 1.5 and see if we exceed the maximum. So our last step is to take 1.5 times IQR and add it to Q3. So that's going to put us at 1.5 times IQR is 25.5 plus Q3, which was 66, gives us what value? Oh, you guys did it before me, 91.5. So 91.5, that is below the maximum here. Right? It's below the maximum. So it means that we're going to end up about here. Let's get rid of that arrow. So we're going to end up like around here, and there's going to be some left over. We don't see the data, but because the IQR is under the maximum of 95, there are outliers. So what was the statement again? If we constructed an outlier box plot, we would see that there is at least one outlier. What do you think? That sounds true now. So 2 and 3 are true. It's not that the outlier will be 95, but yeah, 95 will be one, but there could be more because we don't see the data. We don't know, but there could be more out there. Okay. So outliers would be in here in this range. My arrows are going the wrong way. So outliers in here. At least 95 is one. Christian, 95 is the largest value. So there's nothing over it. It's going to be 95, and there might be other outliers between 91.5 and 95. There could be more values there. Okay. But I don't know because I don't have the data. So I can make a statement. So 95, let me say that. The max 95 is one outlier, but there could be more. Okay, there could be more. I don't have the data to check. So 2 and 3 are correct. So the answer is D. How did you guys do? Let me check how you guys did. Oh. Okay, good. A lot of people got it. Okay. Good show. All right, so we are done, almost on time. And I will put up those 2 homework problems in Moodle. So you remember, we'll start with that next class. And otherwise, we're going to go right into, unless you have any questions for me about this material, we are moving into the normal distribution review. So this week you're going to spend on the normal distribution. And then we're going to do the review next week, and we'll be on schedule. Okay, so do all you can with the normal distribution. For some of you, for maybe half of you, you've seen it before, but This is, well, we're gonna have a week to review or a week to learn it this week. So we can do a similar thing next week where I do some review problems from another source. All right, so have a good week.
Thank you. Have a great week.
Thank you.
Thank you.
Thank you. Have a great
Have a good
week.
weekend.
Keep in
Thank you.
touch.
Same to everybody else.
Bye.
Thank you. Bye.